Okay, how are y'all today? Today we are going to work on the second part of the acceleration force lab. And the way you know what you're looking at is make sure that the blue paper says part 2 right there. And we will be using the data sheet, the back side, that again starts with part 2. The first two tables are very similar to what we did with the last data sheet when we were looking at how acceleration affected force. So this time though, we're going to use the back data. And the first thing we need to do is we need to copy our TA from here to here. And then we need to copy our TB, our time at gate B, from here to here. Go ahead and take a few minutes to do that. Okay, now we need to go ahead and calculate our velocity. Remember, we calculate velocity by taking the distance traveled divided by how long it took to get there or to go through it. So the distance traveled was the 5 centimeters on the wing of the car, and how long did it take for the wing of the car to pass through the gate. So we take our calculator, 0.05 divided by 0.0485 equals 1.03 meters per second. Now keep in mind your data is not exactly like mine. Go ahead and hit pause and calculate your velocity for gate A and gate B. Okay, great. So now you should have both velocities taking care of, your velocities for gate A and your velocities for gate B. So the next thing we need to do is we need to transfer those to the other side. Velocity A is going to go right here, and velocity 2 will go right here. You just again copy that from this side. Velocity 2 to here, velocity 1 to here. Go ahead and take just a second to get those copied. Okay, so now we need to get our delta V, our change in velocity from gate 1 to gate 2. So we're going to take the gate 2 minus gate 1, velocity at gate 2 minus the velocity at gate 1, and that goes right here. So 1.55 minus 1.03, 1.55 minus 1.03 is 0.52 meters per second. 0.53, 0.53, 0.53, 0.59. If you need to, go ahead and hit pause and finish doing calculating your delta V. The next thing we need to do is we need to take the time that it took to get from gate A to gate B and put that right here. So from here to here. Go ahead and take a second and get that done. Again, hit pause if you need to. Okay, great. Now we need to go ahead and calculate our acceleration. And our acceleration is again calculated with our delta V divided by our time between the two gates. So we would take 0.52 divided by 0.3106. So it's 1.67. And again, please keep in mind that your data is not going to look exactly like mine. Go ahead and hit pause and finish calculating your accelerations. Okay, great. Now for the last part. Now we're going to calculate what was the force that the little cars hit the bottom of the ramp with. So on this one, we're going to need to copy a couple pieces of data. We're going to need to copy the mass of the car to the mass of the car, and the mass of the weights. Keep in mind when you did these weights, with 0 weights, we had 0 grams. With 1 weight, we had 190 grams. Again, your data may not be exactly the same. When we added a second weight, we added the amount for the second weight to the first weight to get this total. So write the total amount of the mass of the weights here for each one. Take a second. Okay, next we're going to go ahead and calculate the total mass, and we do this by adding the mass of the car, the MC, to the mass of the weights, the MW. So in the case of the first one, it's 345 plus 0 is 345, and the next one is 345 plus 190 is 535. So go ahead and take a second and get that done, and we'll be right back. Okay, once you have your total mass calculated, you need to transfer your acceleration from up here to down here. And so we have 1.67, 1.74, 1.78, 1.77, 1.98. Now, okay, so now that we have our acceleration, take your total mass and multiply times acceleration. Force is mass times acceleration. So in this case, we're going to have 345 times 1.67 equals 576.15. Go ahead and take a second and finish the column. Okay, so this is what your data should look like now. And so take a look, and how did the mass affect the acceleration, or did it? And then how did the mass affect the force? Go ahead and finish up, and we will have questions over this to complete later.